Hello everyone, my name is Abhishek and welcome back to my channel. As a DevOps content creator, I keep getting this question a lot of times. Are microservices dead? Are big tech companies moving back to monolith? Now, this is a very important question because this changes the equation of learning. Let's say if you have to learn DevOps from monolithic applications point of view, you need to take a different roadmap. Whereas if you want to learn DevOps from microservices point of view, the roadmap is completely different. The tech stack changes a lot. So that's why this is a very important question to ask. And in today's video, I'll provide you a very clean answer. And also, one reason why people keep asking this question, because once in a while, you keep finding articles like this. For example, this article here says Amazon Prime is moving back to monolith. Let's also understand the reality of these articles. This is going to be a very interesting video. Make sure you watch it till the end. By the end, you will get a very clear answer to microservices versus monolith. Let's get started. Let's start with understanding what is monolithic architecture, what is microservice architecture, and what are the pros and cons of these architectures. Let's try to understand in very simple way. When it comes to monolithic architecture, the complete source code lives within a single Git repo, what we also call as monorepositories. So imagine an organization building an e-commerce platform. The complete source code of the e-commerce platform lives within this single Git repo. Not only source code. When someone tries to build the e-commerce platform locally or before they deploy the e-commerce platform, a single package would be created. What does that mean? If the e-commerce platform is written in Java, for example, a single package here means a single war file or a single enterprise archive file would be created. DevOps instance would pick up this package and deploy this package onto the virtual machine. If I have to expand it here, because majority of your DevOps instance, so DevOps instance would create a virtual machine. Within the virtual machine, they would create an application server, something like Tomcat, WebSphere, WebLogic, and place the archive file onto this server. Then they would also create a reverse proxy or maybe a web server. So end user would request a reverse proxy. All the conditions are handled. It can be certificate or it can be rate limiting. Everything is handled within the reverse proxy. And then request is sent to the enterprise archive file. But Abhishek, what about scaling? This e-commerce platform, let's say, should serve thousands of users. Then a simple change that DevOps engineers would do, instead of one virtual machine, they would create bunch of virtual machines. They might do it manually or they might doing with auto scaling, whatever is good for the organization. And on every virtual machine, same configuration is followed. An application server and a web server or the reverse proxy. Now in this case, there would be a load balancer so that end user would make the request to the load balancer and load balancer would balance the request between virtual machines. So this is how scaling is also handled within monolithic architecture. Abhishek, what is the pros of this architecture? Now that you understood the life cycle of the monolithic architecture, this is the development life cycle and this is the DevOps engineer life cycle. What are the pros? Now you must have understood the first thing, this is a very simple architecture. Now when I say simple, I'm not talking about the performance or efficiency, but very simple to develop, very simple to deploy. Even if you're working within a small team, let's say there are only bunch of developers, 2 to 3 QA engineers, 2 to 3 DevOps engineers, this architecture is best because it is easy to develop. Everything is within a single Git repo and it is easy to deploy. You are taking virtual machines, you are following a very basic architecture. And all that you have to do is only deploy one package. You are not dealing with hundreds of packages. The second advantage or the second pro here is that Everything lives within a single code base. So for QA engineers as well, it is very easy to test. Why? The workflow is same all the time. No? It doesn't matter if developers are making changes in the documentation, developers are making changes in the front end, developers are making one line change or 100 lines change. For QA engineers, they execute the same workflows again and again. Why? Because even if it is a one line change, the complete package is created again, the complete package is deployed. So the previous version of enterprise archive file of the e-commerce platform is replaced by the new version. So in that case, the blast radius can be more. So what QA engineers do, they always run the same set of workflows. You might change documentation, you might change front end, you might change one line in the backend. It's not up to them. They would run the regression, they would run the functional testing, all that is required. Along with that, in the monolithic architecture, local building of the application. This is very important for developers because what developers do, whenever they make change to the application, they want to run it locally first. They want to test it locally first. So imagine a developer making a significant change to the e-commerce platform. Maybe they are adding a complete new feature. Now, before they give it to the QA team, before they put it on the servers, they want to run the platform locally. In monolithic architecture, it is easy for the developers because they just have to run one shell script or one Python script to run the application, to build the package, and to run the application on their laptop. It's easy for them to debug as well, right? Because everything is within a single Git repo. So once they have the package running locally, they set up the debugger and they execute the workflow of the e-commerce platform end to end. So once again, this is a very simple architecture, efficient for the small teams, even for the QA team, it is good, and even for the developers. Because it is easy to set up locally, they can run the debugging, they can run the workflows, they can see the complete e-commerce platform running on their local host. Now let's discuss the cons of this architecture. What are the disadvantages of monolithic architecture? There are more disadvantages than advantages. The first disadvantage is that it is difficult to scale the platform. But Abhishek, why is it difficult to scale? Imagine when you decide to scale this e-commerce platform, you would start hiring 50 developers, you would start hiring 100 developers. Now, all these 50 or 100 developers, if they start collaborating on a single Git repo, it affects the scalability in multiple ways. One, in terms of access control, you have to be very careful. There can be junior developers, there can be senior developers. Junior developers might not get the access to the complete Git repo. Senior developers should get the maintainer access to the Git repo. Now, in that case, when junior developers want to fix a bug, or maybe they want to work on a feature, how would you ensure that? So they would land up with the dependency with the senior developers because they don't have complete access to the Git repo. Not only that, when it comes to the scalability of the platform, now in terms of monolithic architecture, all the components are very tightly coupled. So because you have the source code in one Git repo, it might end up, the Git repo might end up with 1 lakh lines of source code or maybe 2 lakh lines of source code. So all the components like payment, shipment, transaction, login, all the features, they are very, very tightly coupled. So if a junior developer wants to make a change to the platform, even if they have access, they should understand the complete source code. So they have to know end-to-end code base, only they can make the changes. Otherwise, they might make changes to the payments, but unexpectedly, they might also make changes to the shipment because the code is very, very tightly coupled. So this way, the scalability of the e-commerce platform would be hampered. Everything is good when there are 4 to 5 developers, but as you start adding 50 developers, 100 developers, the architecture starts showing the drawbacks. Also with monolithic architecture, slow deployment cycles. But Abhishek, you said in monolithic architecture, deployment is easy. Yes, deployment is easy, but it is very time taking. Why? Imagine someone made changes to the documentation, or maybe someone made one liner front end change. But still, irrespective of what is changed, you have to build the complete package. Then you have to deploy the complete package, the complete e-commerce platform on lower environment, then staging, then production. And finally, even on the production platform, you are technically replacing the complete application, version 1 with version 2. Why? Because there is a documentation change. Now, if you follow the canary architecture, or maybe if you follow the blue-green architecture, then you are introducing technically downtime, or maybe you are introducing heavy cost for your organization, even for very, very minute changes. So deployment is easy, but the deployment cycles are very, very slow. It might take 6 hours, it might take 12 hours, sometimes it might take one full day as well if you're going with blue-green architecture to just deploy a documentation change. Apart from that, the maintaining of the source code. Now, I'm talking from DevOps engineer point of view here. The maintaining of source code. How would you manage access control? Right? Let's say a junior developer joined and you only want to grant junior developer access to a microservice that is, or a logic that is not very critical. So within the e-commerce platform, let's say there is products page. Products page is not very critical. Even if the junior developer mess up with the products page, it's okay for the organization. But in Git, at least as of today, within Git, you cannot grant access to the folders. So imagine if this is a structure of the Git. Okay. So this is a Git repo. Within the Git repo, they have created some folders. Product folder, then payments folder, then shipment folder, right? So this way the folders are created. Within the folder, the source code is placed. You want to grant access to the junior developer only to this particular folder. In Git, it is not possible. Either you grant access to the repository or you don't grant access to the repository. You might grant read access, you might grant write access, but that is secondary. You don't have granularity in access control or maintaining the repository at the folder level in Git. So this is another drawback with monolithic architecture. Also, failure, or in DevOps term, the blast radius is huge. Imagine there is a simple bug. Okay, there is a very, very simple bug in the platform that a developer introduced. Maybe developer is working on a change, and as part of the change, developer introduced a security vulnerability. It can be low critical or high critical. Now, once this is placed on the virtual machine, end users would start accessing it. And this security vulnerability can be in the front end, but the blast radius is for the complete application. You cannot say only our front end is compromised. You have to say the complete application is compromised. So the blast radius, when it comes to monolithic architecture, is high. So these are some of the drawbacks of the monolithic architecture. And also, DevOps efficiency becomes less when you are dealing with monolithic architecture. Now let's understand what is microservice architecture. In microservice architecture, instead of dealing with a single Git repo, again, if the organization decides to go with e-commerce platform, initially what the architect would do, architect would break this e-commerce platform into multiple services, and one or group of similar services would be placed into a Git repo. For example, related to payments, there are 4 microservices. all those 4 microservices would be placed in one Git repo. Related to transactions, there are 3 microservices. All of them would be placed in one Git repo. Similarly, Git repo and Git repo. So instead of one Git repo here, what organization does, it might create 30 to 40 Git repos. And each Git repository gets their owners. When I say owner, the development team, the QA team, the DevOps engineering team. This is how a well-matured microservice architecture is designed. And they are responsible, they are accountable for the complete Git repo. And even when it comes to the deployment or packaging, this Git repo has its own CI/CD pipeline. So it would create, if we take the Java application, this would create a WAR file or enterprise archive file. And DevOps engineer of the particular team would only deploy this WAR file onto a virtual machine or Kubernetes cluster. Mostly in microservice architecture, people would go with containers and Kubernetes as the target platform. Right? Same is with this Git repo, and this Git repo. So what we achieve with microservices is granularity. Let me explain the pros of microservice architecture. Then you would understand it better. Okay? At least I hope you got this point clear. In microservice architecture, initially the architect would break the platform into multiple services, and group of similar services would be placed in the Git repos. And individual Git repo gets its own owners. Now let's talk about the positives or the pros of microservice architecture. The first advantage of microservice architecture, every component is individually scalable. So today, management decides we want to scale the payments microservice. So the payments microservice today, let's say only supports Stripe, and you want to introduce Razorpay, or maybe you want to introduce the net banking feature, support for net banking. Now to add both of these things, in the monolithic architecture, the complete application that is in a single Git repository, that has to be touched. But in this case, only this Git repository will be touched. And who will be the responsible person for the payments microservice change? The owners of this Git repo. So it is very clear. If this feature has to be implemented, this dev team is working on it. This QA team is testing it. And this DevOps engineer is responsible for deploying it. Not the whole team, not the whole company is responsible, which is in the case of monolithic architecture. Going back, so the scalability of the individual component is very clear. Now, once the developer makes this change, once the developer adds Razorpay and net banking, then DevOps engineer would take it. DevOps engineer would create a package, and DevOps engineer would deploy the package independently on the Kubernetes cluster. So even the deployment time here will be very, very minimal. You are not deploying the whole platform. You are not deploying 2 lakh lines of code, but you are only deploying, let's say, 5,000 lines of code. So instead of 6 hours, you are only dealing with technically 30 minutes. Whether it is canary model of deployment or whether it is blue-green model of deployment. So what you achieve with microservice architecture along with individual scalability is faster deployment cycle. This is why whenever, let's say Ola, or whenever there is Uber, Swiggy, whenever they make a change, whenever they introduce a feature, it is always seamless. Even Amazon, to that matter of fact, whenever they make a change, the deployment cycles are very faster that you don't even notice. These platforms never go down. Also, the maintenance. In the previous example of monolithic architecture, I talked about it. When I say maintenance, it can be with access control. Now you are quite sure about it. The developers of the payments microservice only get access to its Git repository. They can become maintainers, they can become owners, whatever it is. Even when a junior developer joins the organization, the junior developer only has to learn 5,000 lines of code. They don't have to learn 1 lakh lines of code. Even the tester only has to test the 5,000 lines of code. So maintenance become very, very easy. And even the fault isolation at 2 a.m. in the night, if there is some issue with the payments of the e-commerce platform, the fault isolation is very straightforward. The escalation manager can directly add the owners of the payments microservice to the Slack, create maybe a Slack channel, and ask them to monitor till the issue is resolved. So whether it is incident management, whether it is observability, it is very good with microservice architecture. And finally, this is the most important part. You don't have to force the whole organization on a particular technology. The payments microservice team, they might work with Java. The transactions team, they might work with Rust. Okay. Because sometimes when you're working on a particular service, you might want to use a different tech stack. Maybe in Rust, there is a framework that is very suited for transactions. In monolithic architecture, you have to force the whole company to follow similar technology. Otherwise, it would be a big mess. But in microservice architecture, you don't have to do it. The payments microservice or the transactions microservice, if they want to use the Rust framework, they can go ahead and do it. They only have to deal with this framework within the scope of their microservice. So freedom of technology is quite high when it comes to microservices. So these are advantages of the microservices. You might say, but Abhishek, are there no cons of microservices? Let's say there are no disadvantages of microservices. That's not the case. There are also disadvantages of it. For example, with microservices, your tech stack becomes huge. The best example, you have to go with containers. You have to go with, I mean, it's not that mandatory, but you will move towards containers and Kubernetes. So your tech stack becomes incredibly high. When you are deploying as containers, then you are dealing with pods on Kubernetes. You have to deal with pod to pod security. Maybe you have to introduce things like Istio for mutual TLS. Then on Kubernetes platform, you have to deal with container network interface. You have to deal with the backup of the containers. You have to deal with scalability on the Kubernetes platform. So the tech stack becomes very huge. Not only that, infrastructure as well. Previously, you are creating one or two or maybe bunch of virtual machines. But now, with microservice architecture, you would move to a cloud platform. Then on the cloud platform, you will start using 30 to 40 services of the cloud platform. So just like how there are advantages of the microservice architecture, there are disadvantages of the microservice architecture as well. And finally, one disadvantage, this is not suited for the small teams. When you have a small team with 4 to 5 developers, I wouldn't recommend you to go with microservice architecture unless you have plans to scale that application in the future. In future, you would be hiring 50 developers, you would be hiring 100 developers. Then yeah, go for it. But if you remain startup, if you plan to do that, then go with this architecture, the monolithic architecture, I mean. So these are pros and cons of monolithic and microservice architecture. Abhishek, can you explain in bottom line, like in a nutshell, when to go for monolithic, when to go for microservices? In one line, go for monolithic architecture when your team size is small, when your small team decides to build the complete platform, this is well suited. But if you have plans to scale it, if you want to become a big team, if you want to reach thousands or millions of concurrent users, go with the microservice architecture. Now, finally, when it comes to the news article that I've shown at the beginning of this video, what about companies like Amazon, Netflix, or XYZ moving to monolithic architecture. You might have read some articles on it. Let me tell you one thing. If you read those articles carefully, even the article that I've shown, complete Amazon did not move to monolithic architecture. A small part of Amazon, in fact, a small part of Amazon Prime, not even complete Amazon Prime, a very small part of it moved to the monolithic architecture. Now, the reason is also not very well disclosed. Whatever can be their reason. If monolithic architecture is so efficient, why complete Amazon hasn't moved to it? Why complete Netflix hasn't moved to it? Trust me, the big tech stacks today, they go with microservice architecture. And it is going to be the future as we are starting to deal with millions of concurrent users on the platforms. So today, if you have to start your journey, start with microservice architecture. If you want to learn DevOps, learn with microservice architecture. And finally, microservices are not dead. They are going to be there. It's not a mistake. I hope you found today's video insightful. If you have any questions, do let me know in the comment section. See you all in the next one. Take care.